Tes. Halo, perkenalkan nama saya Dr. Ramadhani, dan di video kali ini saya akan menjelaskan tentang CLO 3 dan CLO 4 assignment part 2. Jadi di sini soalnya itu Geostorm Air Traffic Control or ATC instructs a pilot flying at an altitude of 4 miles to make a 90 degrees horizontal turn while climbing to 4.2 miles. The path of the plane during the maneuver is modeled by this function. So where t is equal is time in hours and all distances are in miles. We have to find the speed and also compute the tangential and normal components of this acceleration of the accelerations. So we have to find the speed, which is like a magnitude of velocity, which is the velocity itself is the first derivative of the sum of a function. This function, for example, so we have to find the first derivative of this function. So the first derivative of this function is this. We will get this, yeah. And after that, we have to find the magnitude of the phi or this function. Okay. After that, we will get this, and we kick this out like, ya intinya agar ini tuh bisa jadi satu nanti, ya, sin kuadrat 10t, yang dimana we know that sin squared plus cos squared is equal to 1, so we don't worry about this. We just compute this plus this. It will give us about 314.17 miles per hour. So we have to find the acceleration then. Acceleration itself is the formula is the first derivative of phi velocity, or the second derivative of this function. So we have to find the second derivative. After that, we find this. Okay, this is the second derivative of this function. After that, we since we know the speed is a constant when we try to this is the tangential component formula, right? So we have to respect this to t, but this is all the constant 314 and 314.17. there is no t. Since there is no t, it means just the constant, so there's no variable of t, so it will 0. Okay, after that, the normal component given this formula, so the final result is 1000 p squared miles per hour, or we can say it's about 9869 point something. Okay, after that, we move to the second problem. A car travel along the curve this way is equal to 1 over 3x cubed, where both x and y are measured in miles. The maximum speed on a curved path is inversely proportional to the square root of the curvature at that point. So we have to find the curvature. Yeah, this is the curvature, and also we have to interpret after that the geometric significance of curvature. So for this, we have to find the first derivative and also the second derivative of this function. After that, we compute the k1 and also the k2. After a long calculation over here, we will get the k1 is equal to this 0.707, and yeah, it's about this, yeah. And k2 is equal to, it's about 0.201. so the formula for this phi2 is phi1 times the square root of k1 over k2, which means this one is k1 and also this one is k2, and v1 is equal to 30, this one. Okay, so we just compute, and 30 times k1 k2, it's about 56.3 meter per hour at the point 3/2, 9/8. So we have to interpret it, right? So higher curvature indicates higher returns. It requires slower speed to maintain control safely. Lower curvature allows for faster travel. So we have moved to the third problem. The temperature in Celsius at the point xy on a metal plate is given by this function. Compute the gradient vector and also find the unit direction vector. Oh yeah, we have to find the unit vector. Okay, we know that the gradient vector has a formula like this: the dt respect to x and dt respect to y for the second point. We have to find the dt respect to x, t respect to x. Okay, t respect to x, we will get this result, minus x times 400 times exponential to the power of minus x squared plus 2/2. And oh yeah, this is supposed to be dy, not dou y, not dou x actually. So it will give us minus 200 times a exponential to the power of minus x squared plus y to the over 2. So we just compute, this is respect to x, this is respect to y, and we have to interpret its direction. The gradient vector points in the direction of maximum increase in temperature in heat flow. In temperature in heat flow, heat moves opposite to the gradient. Okay, and we have to find the unit vector. So we compute first the point 3 and 5. We will get this. Yeah, we just change the x equal to 3, so minus 400 times 3, yeah, minus 1200 times exponential to the power of minus 7 minus 200 times exponential to the power of minus 7. We have to set this, it's equal to 0. Yeah, then we have we did the substitution over here, like we have to find the a and b. So after we have to divide this all by 200, and we will get this minus 6a minus b is equal to 0. It means minus b is equal to minus a, is equal to 6a, right? And we reverse, kita balik lah intinya. Jadi b is equal to minus 6a. Then we know that any vector of the form a, minus 6a will work. And the last problem, a candle manufacturing company produce candles at 2 locations. The cost functions in dollar per producing x1 units at location 1 and x2 units location 2 given by this function, and each candles for $15. The total profit is this. So we have to compute we have to masukkan ini ke sini, masukkan ini ke sini. We have to find the value of x1 x2. It's just the same, like we have to find the critical point of x and y, right? So yeah, just the same way interpret. Okay, so this is the equation, right? The total profit. So we just change this with this and change this with this, so we will get this. Okay, and after that we just like apa ya, kita minusin yang sevariabel seperti ini dengan ini jadinya 11, ini dengan ini jadinya 11, dan juga and also this with this, so it will minus 775. So after we got this formula, we have to respect maksud saya ini function ini kita harus dapatkan derivatif respect x1 dan juga x2 ya, kembali lagi. Jadi so it will give us this ya, from this and times maju ke depan jadi 0,04 x1 ya, minus. Kita set ini jadi 0 dimana kita mau mencari critical point-nya. Jadi kita tahu berarti ini kan minus 0,04 x1 sama dengan minus 11. Kita ubah ya, kita reverse dua-duanya jadi ya seperti ini, 0,04 x1 sama dengan 11. Jadi x1 itu berarti is equal to 11 over 0.04 is equal to this number. And for x2, respect to x2, yeah, almost the same, but this ini maju ke depan jadi minus 0,010 ya. x2 dari x2 atau ya, anggap aja itu y. Nah, so we will get this equation. We set this also equal to 0, and after that we know we substitute like minus 0.10 x2 is equal to minus 11. So we just reverse it to supaya jadi positif. So x is equal to 11 divided by 0.10 is equal to 110. So this is the final result. So we know the critical point and interpretation. Location 1 should produce about exactly 275 units, and location 2 should produce 110 units to maximize the total profit. So that is my explanation about this, about my assignment. Thank you for watching.